Hey guys, Mrs. Traver here. Today we're going to talk about angles of regular polygons. This is a 2-day lesson and here comes day 1. Our learning target for both days is that you'll be able to find the sum of the interior angles of a polygon and be able to use those properties to solve problems. You know you'll be successful when you can determine the degrees of central angles and identify convex and non-convex polygons. Let's jump in. First one I want to show you is something you've seen before, which is the sum of the interior angles of a triangle. As we know, the sum of the interior angles of a triangle, so the Triangle Sum Theorem is what we call it, where we have the symbol sigma, which means sum, is that all of the angles, in this case the measure of angle A plus the measure of angle M plus the measure of angle T, add up to 180 degrees. We're going to use this fact throughout the entire lesson. So with this triangle, we can see we already have 2 angles given to us and we're missing the last angle, measure of angle T. So we can start with 180 and take away our 82 that was used for measure of angle M, and take away our 27 used for measure of angle A. We'll be left with, let me grab a calculator, hang on. Let's see, 180 minus 82 minus 27 is 71. All right, so that means measure of angle T is 71 degrees. Let's use that with our next slide. This time I don't have a triangle, but instead I have a rectangle, and I want to still find the sum of the interior angles. Now it's not going to be 180 like a triangle, but what I can tell is that this rectangle I could actually break up into 2 triangles. And if I label all these angles, I'm just going to label them with numbers, 1 through 6. I know that angles 1, 2, and 3 would all add up to 180 degrees, and angles 4, 5, and 6 would also add up to 180 degrees because that's the Triangle Sum Theorem. Now, if we notice that the angles within the rectangle are 2 plus 1 plus 6 plus 5 plus 4 plus 3, all of those, it should just reason out that this makes 360. So the sum of the interior angles of a rectangle is 360. Now, mind you, this will work for any quadrilateral, not just a rectangle. So, for example, if I had a parallelogram, I could also cut it into 2 triangles. Or if I had a trapezoid, for example, that was kind of a bad trapezoid, but I could cut it into two triangles, or a kite. Any of them will work. You can make 2 triangles out of them in several ways for the most part. So my point is that we're going to notice that when we have shapes that are bigger than triangles with more sides, we just need to cut them into triangles and then multiply by 180 for how many we had. Let's see that on our next slide. Here is 1, 2, 3, 4, 5 sides. That's a pentagon. The sum of the interior angles of a pentagon now we can find by, again, cutting it into triangles. So I'll cut it here, and I'm going to cut it again, I think, here. The easy way to cut it, I think, is just start with 1 vertex and just go out from there. So let's see, we have 3 triangles now. So that means we would have 3 times 180 for the sum of the interior angles of a 5-sided gon. So 3 times 180 is 540. So that means we have 540 for the pentagon. Now, I want you to notice something. A triangle had 3 sides, and it had the sum of the interior angles was 180. That was like 1 times 180. For 4 sides, we added another 180 to get 360. For 5 sides, we added another 180 to get 540. And each time this triangle, this 3-sided gon was cut into 1 triangle. This one was cut into 2 triangles. This one was cut into 3 triangles. We're going to use that on our next slide because now we'll be able to figure out the sum of the interior angles for any polygon. So let's look. We know the sum of the interior angles for a 3-sided gon can be broken into 1 triangle because it is a triangle, and its sum is 180 degrees. The 4-sided figure, like the rectangle we saw, could be broken into 2 triangles, and it was 360 degrees. The pentagon was broken into 3 triangles, and it was 540. And let's see, notice that 5 to 3 was minus 2, 4 to 2 was minus 2, 3 to 1 was minus 2. Let's do that again. I should be able to get 4 triangles, 5 triangles, 6, and 7 if we carry out. And I think each time we'll just multiply by 180. So 4 times 180 is 720. And then I could add another 180 to get my next one, 900. Plus another 180 would be 1080. And then plus another 180 would be 1260. The trick here that we'll notice is that each time we do this, we're taking the number of sides, taking away 2, and then multiplying by 180. That, matter of fact, is the formula for the sum of the interior angles. So in this case, if we had 100 gone, I could take away 2 from 100 sides, which would give me 98 triangles. So this is the amount of sides, and now this is the amount of triangles. I can multiply that by 180, and that should be the sum of the interior angles. Let's see, 98 times 180. Big number, 17,640. That's the sum of the interior angles of 100 gon. I think we're ready for the formula. Here it comes with this one. I noticed that there's a regular polygon, and I've got 1, 2, 3, 4, 5, 6 sides, so that'd be a hexagon. If I take 6 minus 2 is 4, that would be the number of triangles, and then I could multiply that by 180. That'll give me what all of these add up to. So let's see, 4 times 180, that was back a couple slides. 5 sides, 4 times 180, 720, there we go. Too far, 720. So all of these add up to 720, and I had 6 of them. So I could just cut it into 6 pieces. Let's see, 720 divided by 6 is 120. So each one of these is 120 degrees. And looking at this picture reasonably, I know 90 is about here, so it's a little more than that, and that makes sense. Here's another one. This time they're all different, but I know the sum of them. So let's see, I have 1, 2, 3, 4, 5, 6, 7 sides. So let's find the sum of them first. That'd be 5 times 180. So the sum of them is 900. And I'm going to start taking away numbers here. So I'm going to start with I'm going to start here with the 106, I decided. So I'm going to start taking away numbers. Oops, sorry. There we go. Please stop. There we go. I already used 106, I'll take that away. I'll add the 9 to undo it. I'll subtract the 133. I'll subtract the 120. I'll subtract the 13. And I'll subtract the 138, enter. Okay, so I'm left with 399. And it looks like I have 1, 2, 3 m's to cut that into. So I'll do 399 divided by 3 to get 133. So there we go, m equals 133. Now on my calculator, by the way, I really set up this big equation and was able to solve for m. All right, let's check out this last one here. We have a pentagon on the bottom with the triangle on top, and we're trying to solve for k. I think that what we might have to do is look at the triangle first before we get down to the pentagon on the bottom, because we're missing some angles up here. If I knew this angle here, I'd have all of them in the pentagon and I'd be able to solve for k. So I think let's use the triangle first. And I know that it's an isosceles triangle, so these two bottom base angles will be equal. So let's use that fact. Starting with 180 for the triangle and taking away our 64, we're left with 116 to split between the two base angles. So I'll cut it in half and see each of these angles are 58 degrees. I can now use supplementary angles to solve for this last angle in the pentagon I'm missing. So I can take 180 minus 58 and see that this angle is 122. Now I'm in a good spot because I have all the angles in the pentagon. So let's see, a pentagon has 5 sides, so its sum of the interior angles will be 3 times 180, or 540. And then I can start taking things away. So I already used 122, I'll take that away. I already used 90, I'll take that away. I already used 96 and 88, and I'm left with k, which is 144 degrees. All right, I want to wrap things up here with you guys and show you the formula we've been using the whole time in action. So when we have the sum of the interior angles, we look at the number of sides and we call that n. So if n is the number of sides, all we do to find the sum of the interior angles is we take away 2 from it and we multiply it by 180. So this is usually how you'll see it. The sum of the angles is 180 times n minus 2. I will see you next time, guys, for day 2, where we'll do more practice of this lesson. See you then.